All right, hey folks, welcome back to another part of my thing where I'm trying to get better at Tetris. And I'm going to do that by creating a program to extract the necessary information from the ending screen of a Tetris game. And I must say, this week I got a CRT monitor, or was that last week? And it's made playing this game a whole lot easier, and as it should be. Anyway, regardless, this is what we're after. This screen right here. This is where we want to extract all the statistics and the score and the level and the lines and save that all to a database so that we can watch ourselves get better as time goes on. And I had the brilliant thought this week of using it to actually update a live video feed of someone playing the game, and we can determine things like Tetris rates and burn lines and these new kind of Tetris statistics that weren't in the original game but have become popular these days. So that's my lofty goal. So let's do it. Let's carry on with what we're doing. So if you recall last time, I was trying to extract the information. What's going on here? I was trying to extract the information from an actual bitmap. So here's the canonical number 1, say, and we wrote some unit tests, which we're still debugging here. So we wrote these screen reader tests. We got this screenshot, which is this one here. That's too big. Why can't I? Oh well. We got this screenshot of a game I played that I got to 195,640, and I was trying to extract the score from it. So I know what the score is. I have the image. I wrote this test, and it wasn't recognizing the 1 properly. And so I hacked it to recognize the 1 because I thought it was a little bit odd that it wasn't recognizing the 1. Oops, we'll get there eventually. And so I hacked it, and then I went on to try and recognize the 9, and it didn't work either. So the very first thing I want to do is get rid of my hack. Now, we came up with these numbers based on the canonical images which we got. It's based on this image right here, this number 1. And this number 1 right here is not quite identical to the canonical one, which doesn't make any sense to me because these are all screenshots taken from an emulator, and so they should be consistent, but they're not. So the very first thing I want to do today is to take what I'm reading as a 1, and I want to just output it to a file just to see what it is that we're trying to get. So I load in the image, I create a new screen reader from it, and I'm putting a value pixel 1056-267. So that pixel is, there we go. That pixel was like right here, 1056-270. And then I was drawing a little box around it, getting that 1, but it wasn't identical to the 1 we had. So what I'm going to do is try and output what I read in and see if that makes any difference. So let's do that. So this was my method to get the value. You go to this x coordinate, this y coordinate, and you're going to go this you want the 6 digits at that coordinate. And that used the math of how wide a digit is. Up here, we have our X width and Y height, 45 and 39 pixels respectively for this particular screenshot. What's going to happen is we're going to standardize the size of these images eventually, so we can, my hope is to do this with the fuzzy graphics of an actual Nintendo, which I have right here, going through my capture card. Because the idea is to record my score, whoops, there goes my controller again, and track how I do, but the running it on an emulator on a computer is not efficient. The best experience is a CRT, and it actually makes the game easier. So that's the goal, but let's get it working in an ideal situation right now. So, I just want to make sure I'm recording as always. Okay, so I want to take this digit here. So we were getting a value. The screen reader takes in the entire screenshot, and the get value at method took an XY coordinates and a number of digits, and it created a crop area of that for the 6 digits, in our case, the 6 digits of the score. And then we cropped the big image into a sub image, which is just the crop area. Now, then I took that crop area and I went through each of the digits and I tried to recognize them. And I got the 1, but it wasn't identical. I went to the 9, I got the 9, but it wasn't identical. So, right now, we go through each of the columns. Here we get the digit image. This is the image of the digit. At this point, my guess is that it's identical to my canonical test number 1 right here. And again, we've used percentage of black pixels. So the actual positioning of the 1 inside the box doesn't matter. But for some reason, it does matter. Well, I don't think it's the positioning of the 1, but we're going to find out, and then we're going to fix it, because it's going to unearth an oversight on my part. So, let's begin. Question is, no, not here. We have to go into here, get value out. So here's my digit image. I want to actually just, there's no way to look at an image while you're debugging. So I'm going to have to output this digit image. Now, is there like a, ooh. There's a save? What? That would be simple enough. What does this actually do? Save it to a stream with some save it to a file name. Look at that, folks. Well, that's excellent. Let's save this. Whoops. Let us save this thing. That's all we want to do. So I can just call digit save and then a file name. Okay, so this is our digit that is 1.bmp. So here we go. Digit that is 1.bmp. We're going to save that. I'm going to run my test. Actually, let's make sure. We'll put a breakpoint here. We'll run my test. Actually, no, we don't have to put a breakpoint anywhere. We're getting the 6 digits. The issue is if I go through all 6 digits, it's going to... Oh! No. It's probably best for me to save each digit. So what I'm going to do is I'm going to save it as digit that is... Then I'm going to put an underscore and the column number And that way I'll save each one of the digits that I'm looking at. And then we'll look at them and we'll be able to tell what the problem is. So let's run this test. This test is actually going to save the files. It's still going to fail because we have this assertion that is 195640 at the end. Come on. Did it run? Okay, did that work? We're gonna go show all files, debug. Interesting. What's just happened here? Where's the thing that saves it? Debug. That's standard. Sorry folks, it didn't save it in the file that I thought it was. The Tetris data extractor. This is under digit recognition. Bin debug Netcore 3 app. Those are my canonical digits. Oh, Tetris data extractor, digit recognition, bin debug. Yeah, okay, whatever. I still have this Tesseract data nonsense going on. Where's my digits? Digit that is 1. Well, there it is. Where open file location. Oh, it's in my tests, of course. That's, yeah, okay. Okay, digit that is 1. Oh, digit that is 0. Oh, digit that is 0. Oh, that is in column 0. Okay, in column. So how? Column is less than num digits. Okay, let's. You know what? I'm gonna clean my solution because it's getting a little bit crazy here. Okay, we'll run the test again. Let's run the test again. We'll see what happens. Looks fine to me. And again, it's not going to work, but that's okay. We'll show all our files. Go into the bin, debug this one. Whoa, there's a lot of stuff in here. So digit that is column in column 0 is a 1. So my question is, what the heck is different? Between this one and my canonical one. So let's open up. I'm not sure how. Maybe I should do this in GIMP. Let's open up GIMP. Let's open up both canonical, both the digit that is in column 0. Here it is. It's a 1. We're gonna okay, so that's my digit that is in column 0. We're gonna open the canonical digit now, which is somewhere. This is under this one, no, this is under tests as well. The digit recognition test images, the one. So we'll open up this. So these two, they are offset from one another. You can see that. If I increase this to, say, 400%, and this one to 400%. But I mean, they should be identical. If I copy this, what just happened? What did I touch? Go into here and paste it. Maybe if I make the here, let's remove this layer. Let's delete it. Delete layer. Let me select my colors. Select by color, black, and we will, I think we can just clear it out. No, let's choose a weird cyan color. There we go. Okay, so there's my one. Now I'm going to select all, copy this, go over here and paste. No, I needed the alpha channel to be different. Ah! Add alpha channel. How come I can't do this? Man, this is not what I had in mind at all. This one looks the same as that one. Look at it. It's the same thing. I was trying to overlay them just to see what kind of pixel would be different, but the sizes of the boxes are the same. They look the same. Like, they honestly look the same. The only thing I can tell that's different is the positioning of them on the screen. So what I'm going to do, we'll collapse everything. Okay, so in the digit recognition, the test image, which is the one, we are only going to run the one here. Okay, so we're just gonna, this is the canonical, this will ensure that the canonical one works. And it does work. In my screen recognition program, let's just get the value, the 1-digit value, and this should be 1. Okay, we're not going to go over each digit. And this doesn't work. Even though the ones are the same, they look the same anyway. Okay, so I'm no longer going to save this. We'll just comment this out. We might want it later on. What I'm going to do, in our get digit, we calculate the fingerprint. Here we calculate the fingerprint. I'm going to put a breakpoint here. Actually, let's go into here. I want to put a breakpoint in here. So first, we're going to see a few things because the percentage is slightly out of whack. I'm wondering if it's slightly a different resolution or something, which is slightly causing the percentages to go weird. So we'll run our screen digit reader tests here. And we'll debug this. There's only one test now running against the 1. What I'm doing now is I'm trying to find the actual number of black pixels. So the total pixels is 1755. That should be the same. But I'm going to write that down because both images should be the same. 1755 total pixels. And that should be just 45 times 39. The black pixels, then we're going to run until we get to here. And what are black pixels? 1246. Okay, so 1246 out of 1755. And that gives us our 70.997, which tells us that it's a 1, which is why this one passes, which is kind of a circular reasoning. We made the test for this test image, so it better pass. But my thought was all the ones were going to be the same. So now we'll debug this one, and I expect to see the exact same numbers. So I want 1755 total pixels, which I have. And then we're going to run to here, and I should see 1246, and I see 1241. There are 5 less black pixels on my... No! Okay, so that's why, 1241. Okay, so what we're going to do... and of course it throws an exception because it doesn't know what that is. So 1241 black pixels. Let's go back into our screenshot. Do we have another 1? See, we have another 1 up here in the line. So let's have a look at that. Let's get the pixel value. I don't think I can get the why do I have diagnostic tools when I'm not even debugging? Odd. Okay, let's go back to GIMP then. This was our screenshot. And I'm just using the pixel coordinates down at the bottom left. So let's go pixel 840, and then I will draw. Oh, I'm still. No, I just want the select tool. 8, yeah, so if I start at 840.75, I could go all the way to 880. Oh, check that out. That's the box size that fits around this one. This one, it kind of does too. I just have to... So what is this top pixel here? 837? 74. Okay, let's do that. 837, 74. And again, we're just going to get the single digit, which according to our picture should be this number 1. Let's debug this. And again, we're going to see 1755 total pixels in the square, which we do. And the black pixels, what is it going to be? 1246. Interesting. So this will actually pass. That'll actually pass because interesting. So this one has 5 more black pixels than this one. Huh? Okay, that's all right. Let's look at this one. I do have a level counter here. See, I did not expect this. How are they different? So let's go from 1143, 769. So what is going to be similar? Is it the score one or the lines one? This is like a competition here. But what this is telling me, 1755, is that we can't rely on the same values all the time. See, this one is 1241. So this is like the score. Let's put this back to 100%. So this one is identical to this one. This one has 5 more white pixels. And now see, here's the issue. 5 more white pixels is going to be hardly noticeable. I'm going to fill this. How come I can't fill that? Why can't I fill any of this? Select none. Bucket fill this. Okay. Now I'm going to copy it. Copy it. I'm going to paste it. Here it is. Actually, you can come and help me. Yes, this is my wife, everyone. She's going to remain off camera because she's shy. She's a GIMP expert. So I have this number 1 that I want to remove the black. So that's transparent. It's a floating layer unto itself.
Yeah, I know. It's just you set up your tools differently than me.
Can I just clear it out? Like add an alpha channel here?
Yeah, you can do that. Sometimes you can like color select.
Yeah, that's what I did earlier. And then clear.
Maybe color select, add alpha channel, and then delete.
Oh. So select by color.
Then right click.
Add alpha channel. No, it doesn't really.
We must be using different versions.
We are using different versions. Because this one I want to.
Sometimes you can't on floating layers.
So how do I make it not a floating layer?
You pasted it instead of pasting as new layer.
Yeah, so I can just. I should just delete it.
That.
Delete it.
It's easier if you just paste everything as a new layer, and then you can manipulate it.
Whoa. Select none.
Selecting.
Okay, so here we go. This one, I copy, and then I paste.
As new layer.
Paste as new layer. Cool. And so now it's here. No. Where's my pasted layer? Oh, because I need to move it around. Good, so that's there. And now I can select by color.
Yeah, I think you just can't do a lot of things.
Clear it out.
When it's a floating layer.
That's perfect. This is exactly what I want. Because now, look at that, folks. Thanks, honey.
You're welcome.
So that's why. Look at, there's the 5. You need to get in here? Just 1 second, folks.